Welcome to another lecture for our PLC course. In this lecture, we'll be discussing about the timers for Allen-Bradley PLC. So, in Allen-Bradley, there are basically three types of timers available. Let's say, let me put it in the slide mode, then it's easier. So, the first timer we call T-on timer or on delay timer. So on delay timer or T-on timer. So, and the second timer is called T-off timer, and the third one is called retentive timer. Okay, so these are the timing diagram for T-on, T-off, and RTO timer. RTO means retentive type timer. And but before we go into the discussion about this timing diagram, let us first discuss the memory storage of the timer. So basically, there are three stacks of memory, which are each stack is 16-bit of memory, and the lowest stack has the accumulated value, and the middle one has a preset value. So what is the accumulated value and what is the preset value? The preset value is the value that will define the total delay that we need for the timer. And we have another thing called timer base. So timer base can be 1 second, could be 0.01 second, or could be 0.001 second. So let's say you have a preset value of 50 and your time base is 0.01 seconds. So your total delay would be time base times the preset value, which is for this case it would be 0.5 second. But let's say if you have a preset value of 5 and your time base is 1 second, then your total delay would be 5 seconds. Accumulated value is basically the value will be changing, keep on changing based on the time base from 0 to until the preset value. So once the accumulated value and preset value will be equal, then there will be some changes in these bits. Which we will discuss later on. For different timers, it will behave differently. So the uppermost stack has the 12-bit, until the 12-bit is used for the internal use, but the last 3 bits are accessible by the user, and these are the bits that we will be more interested in. So the 16-bit is called the enable bit, and then then we have the 15-bit, and then we have the 14th one is the TT or timing bit, and then this is called the done bit. TN is for the done bit. Okay, let's say for the T-on timer, it is pretty straightforward. You have an input, okay, maybe a simple maintain contact, and you want to use this input to turn on a device, but you want to turn it on after certain delay period. So what will happen? So you turn on this maintain contact by changing the status. So it will become from false to true. So your timer will become enable immediately. So this enable bit will become true immediately, and your timing will start to count the time. So your accumulated value will keep on increasing, and once it is equal to the preset value, then timing has been finished. It will become false, and your done bit will become true. So you are delaying 15 seconds to turn on this device. Let's say another scenario. If we talk about that, we turn on the input, but you turn it off again after 7 seconds. So your done bit has no time to be turned on. So your device will not be on at all, because you have stopped, you have closed the switch, or you have basically made it false before the timing finished. The timing is accumulated before the accumulated value reaches the preset value. Okay, so this is the case. Now, once this happens, basically once your timer becomes false, or the enable bit becomes false, immediately your timer accumulator value will be going to 0. That means it will be reset automatically. However, for the case of retentive type timer, it is not the case. Let's say your input is true, so enable is true, and you start to count the timing, so timing starts to becomes true. But after 4th second, let's say your total delay is 11 seconds, and after 4th second your input is false, and so your timer will become false, but your accumulator will still remain at the 4th second. And then let's say after a certain period of time you turn on the switch and your enable bit will become true again, your timing will start to count again, your timing bit will become true, so this will start to count, and from the 4th second, not from the 0th second. So until it reaches the 11th second, then your done bit will become true. So this is the difference between T-on and RTO timer. So because RTO timer, the accumulator value does not go back to 0 automatically, so that's why we have to use a reset button to reset the timer. So you have to have a separate reset button to reset the timer so that the accumulator value can be brought into 0 again. Okay, TOFF timer is a little bit different, unique in nature. So the purpose of using TOFF timer is that you turn off a main device, but still you want to keep your sub device, another auxiliary device, to be activated until a certain time has been lapsed. So I repeat, so you turn off your main device, but still you want one of your auxiliary device to be still activated until certain time has been passed. So let's say this is the input is become true, so the enable becomes true, but the timing will start to count once your input again becomes false. So your input becomes false, then your timing start to count time, and your done bit is true immediately when the enable is true. So this is the difference. You can see here the phase difference. And done bit will become false only when the timing is finished. So then the done bit will become false. We will see what are the uses of this type of 3 timers with 3 examples. Then it will be much more clearer for you. Okay, let's go to the next slide. So the first example that we are going to see is the use of the T-on timer. So what we are doing here is basically we have a large pumping system, maybe for a big irrigation system, which has many valves. And when the system is on, it is highly recommended that to delay the turning on of the pump by a few seconds, so that we can ensure that all valves are properly open to avoid any excessive pressure buildup. So this is the case. Let's see. Okay. So let's go into our emulator and see what can be done. So I have already written a program. As you can see, 3 programs for the 3 examples. Let me put it in maximize mode. And I have shown in the earlier videos that how to write down the program and how to upload it to your emulator and how to set up all these things. Please refer to the previous video for setting up the RSLogix simulator software. Okay, so we have done all these things, and now you can see here. So basically this is the example for the T-on timer. I have put some comments. This is the comment and the title, which you can do by selecting this one and then right button, and then you can see edit title or edit comment. Then this thing will pop up, and you can select attach to file or run, and then you can put the title of the particular program, and you can give the comment for the run title and run comments. Okay, so basically what we have here, as I have mentioned, we have a switch to turn on. We want to delay the turning on of a pump. So what happened here, let's put it in fine, see what happens. Okay, so we maximize it again. Okay, so what happened here is the selector, we are not directly connecting the selector switch with the pump. So this is a maintain contact. Let's say it's not a push button, it's a maintain contact. So we toggle the switch and see what happens. So we toggle the switch, we can see that the pump is still not on. So it has been, there is accumulator value is going up, and once it hits the 10-second, then basically you feel your pump is turned on. So basically the time base here is 1 second and preset value is 10. So total delay is preset value multiplied by the time base, which is 10 seconds. So as you can see here, we turn on this device, and then we basically delayed the pump operation by 10 seconds. So we toggle it back, so we off, so your pump is off. But you turn on the pump again, and it takes 10 seconds for the pump to be turned on. So you can see this one, this is the case. So we toggle back. So this is the first example, which is pretty straightforward. Let's go to the second example, which is a high speed. So let's say we have another scenario. This is to show the use of TOFF timer. Let's say we have a high speed milling machine which has a spindle that can rotate at 70,000 RPM, and it takes a few seconds for the spindle to come to a complete stop due to the inertia. So once it is rotating at 70,000 RPM, even if you turn off the machine, it takes about maybe 10 seconds or so for the spindle to come to a complete stop due to the inertia. Now during machining, when the spindle is running and it is cutting the metal, so during machining, a safety door is maintained to be closed, of course, because there's a high-speed tool is rotating, and we should not, operator should not put their hand into the working zone. So there is a safety door which will maintain to be closed during the operation. But we want to ensure that the spindle should come to a complete stop before the door is opened back again. So even if you stop the machine, because there is a delay to for the spindle to come to a complete stop, so we have to do something with the PLC so that the door can be opened after a certain period of time, even if you turn off the machine earlier. So let's see the solution here. So still we are in the run mode. So this is the TOFF timer example that I have just explained, the solution for that example. So as you can see here we are using a push button start button, which means a push button start, which is basically a spring loaded momentary contact. So that means if you press your push button with your fingertip, it will be on, but if you remove your hand from the push button, it will be off. Same goes for the stop button, which is also a momentary contact, but this is normally closed mode. So what happened here is basically once I press the push button, this motor, or basically the machine, is on, and we also trigger the TOFF timer. Now then what happened here is basically, because as you know, this from the timing diagram, basically if you can see, once the input is true, enable is true, and your done bit is also true. So I'm using this done bit to basically, as you can see here, the done bit to basically control the door close button. So that means this door close output is controlled by the done bit. That means once the machine is on, the done bit and the timer is already enabled, so the done bit is true. So basically your door will be immediately closed. Now let's say I stop by pressing this button. I stop this one, so the machine will be stopped. So that means your timer is no longer enabled. So what happened here? So if the timer is no longer enabled, then your timing will start to count the time. Excuse me. So your done bit will be false after finishing this timing. So your door will be closed, will be open after you finish counting the time, which is 10 seconds in this case as well. So let's see what happens. So basically we can toggle this, and then motor is on. We untoggle because it's a push button, and then you can see the door is closed and nothing has happened because we haven't started the timer yet. Timer will be started once I press the rung becomes false. So I toggle this one then, and I toggle it back again, and you can see the timer has started and still the door remains closed. So once finish this one, then the door becomes open. So you can see, even if I press the stop button, not immediately, your motor goes immediately stop, but not the door. Door opens after 10 seconds. So I toggle it back again to show you that the motor is started and the door is closed immediately. I toggle it back again with this push button. Now I press the stop button. So you can see motor is off, but the door is still closed. And then after we toggle it back, after a certain period of time, basically your door becomes open. That means the door close button will be activated, not activated, so we can open the door now. So this is how the system works. Okay, let's say now the example for the retentive type timer. So the retentive type timer, it says that we have to design a ladder program so that we can track the machine's cumulative operating hours for some maintenance purpose. For example, a machine may have a lubricating oils and all these things, and we may have to do the changing of the lubricating oils. So so after a certain period of operation, we need to do that. So we have to design a ladder program in such a way that we can track these total operating hours. And then after that, if you do not change the lubricating oil and reset the timer, you cannot basically operate the machine anymore. So this is for preventive maintenance purpose. So let's see what happens to this solution. So basically what happened here is I use a selector switch again. It's not a maintain contact. It's not a push button contact. It's a maintain contact. So it's a selector switch, and we use basically an output to turn on a machine. Okay, it can be any machine, and at the same time we basically turn on an Rto timer. This is Rto timer. So for this purpose we put only 30 seconds, but actually in real life it can be several hours of operation. For example, 10 hours or maybe 100 hours or so. But because it will take a very long time to simulate, so that's why for the simulation purpose, I just put here 30 seconds. Okay. So now let's say you have a 30-second. So what happened here is basically somehow this my previous I forgot to reset the accumulator. Let me reset the accumulator first. Okay. So now you can see the accumulator value is 0. So once I turn on this one, I'm using this timer done bit as a normally closed condition, so that there's a reason for it. So this rung will become true, so the timer will be enabled, and then it will keep on tracking the time. And once the accumulator becomes equal to the preset, the done value will become true. So your normally closed will become open, so you cannot turn on the machine again unless you reset the timer using this reset button. And once the done bit is true, you want to show a light to be turned on to show the user that it is time for maintenance. So let's see what happens. So we toggle this one. So you can see the machine is on and the timer keep on ticking. And then you can see here, let's say now I have off the machine. Okay, so you can see here the accumulator value remains 15. It is not reset back to 0 automatically. So what we have to do here, next time we want to do the machining again, and we toggle the bit, we start the machine, and it started from the place where it was left. So now 20, and then I turn off again, and then you can see it has stopped at, I suppose, in 22 seconds. So now I turn on again, and you can see it has started again. And then once the 30 it hits the 30, let's see what happens. You can see you cannot on the machine because this becomes normally close, becomes open, and the machine is off automatically even if your selector switch is on. And you can see the maintenance timer has been shown here, so that means you have to do the maintenance. And then so you turn off the machine, okay, and then after you do the maintenance, finish the maintenance, and then you press the reset button. So this is a normal push button reset button. So we toggle and then we untoggle again, and then you can see here now you can turn on the machine again. You can toggle it back and you can see you can turn on the machine again after finish the maintenance. And now again, let's say it hits the 30 second, then again you have to do the maintenance one more time. So let's see what happens. So you stop at the middle somewhere, and then you start again. And you can see the machine is off and you need to do the maintenance. So again you have to finish the maintenance. So you turn off the thing, you finish the maintenance, and then you reset. So it's a push button, so once toggle and then it should be untoggled again. So I hope this basically clears up the 3 examples and on different types of timers. If there is any question, feel free to contact me at tanveers@iium.edu.my. Thank you very much. Assalamu alaikum warahmatullahi wabarakatuh.